I became interested in weather when I was little. So I just found that weather fascinated me when I was in grade school at the time. Wow, that ridge of high pressure sure giving us a nice day today. Look, it's sunny and looks like it's going to warm up nicely. Wow, look at that. Another beautiful day. That ridge is staying right where it is, and it's going to be even warmer today. Wow, look at that. 3 days in a row. Beautiful weather. Although it's getting a little warm today. But the good thing is tomorrow it's going to be a little cooler. We got some storms coming. Oh, the clouds are gathering over the higher mountains. Looks like a problem. Let's go back to base. What happens again when you get a really, really tall thunderstorm, it gets very cold at the top of the storm, and so rain will freeze and you'll end up with ice in the storm. And if you have a really strong updraft in your storm, it'll keep ice circulating near the top of the storm and gathering more moisture and getting larger and larger and larger until it becomes so heavy that it falls out of the storm. And that's why we can get hail of pretty good size, maybe baseball or even softball size hail. Boy, today's a different day. Look at those storms gather. Look at all that lightning.
It looks like there's some large hail as well. I think I'm going to issue a warning.
It sounds like a good idea.
So what's a severe thunderstorm warning?
Okay, when we have a number of hazards with our thunderstorms, you know that a tornado warning will be issued for tornadoes and flash flood warning will be issued for flash flooding. But other hazards exist like hail and wind. So we have a severe thunderstorm warning if you're going to have large hail at least an inch in size or strong winds at least 58 miles an hour. And so one of the challenges with severe thunderstorm warnings is that we get stronger winds than 58 miles an hour and we get larger hail than 1 inch. So sometimes here in Colorado you'll see hail of over 4 inches, for example, or winds over 100 miles an hour out of thunderstorm.
Help! Help! My parents are home.
A boy in distress, I will save you.
Super weather guy!
Let's teleport to safety.
We're finally to safety. Thank you, super weather guy.
Now that's quick thinking.
So tell us all you know about lightning.
Okay, so what happens when a thunderstorm gets very, very tall is that ice forms in the storm, and in the updraft you'll have a lot of collisions of all this ice of various sizes, and that causes static electricity and discharge. So positive charges go way up to the top of the storm with the lighter ice crystals, and at the bottom of the storm the heavier, bigger ice crystals collect negative charges. And so what this looks like is a battery. Positive charge on one side, negative charge on the other. And then what happens underneath the storm, because of all the negative charges near the bottom of the storm, you get positive charges that travel with the storm. And what happens is that those positive charges try to reach the negative charges. And so they go up telephone poles and houses and people. So if you've ever been under a storm and your hair starts to rise, that's those positive charges trying to reach the storm. At the same time, these negative charges are going down in what we call step leaders, like this. And then at some point, the negative and positive charges are going to meet, and that's when lightning occurs.